Hello, this is math teacher Barbie, and today let's talk about arrays. So first idea, what is an array? What we're talking about when we use the word array is a way of organizing items or data in some sort of orderly fashion. And in math, we're usually talking about arranging it in a way, in a rectangular and regular pattern that makes it easy to count and to see how many there are and to put in some sort of order sometimes. So in school math, we're going to use arrays to build fluency in counting and skip counting and adding, to make these skills more rapid, more fluent, more easy to access for children. We're also going to use arrays to be a visual and when they're touchable or when we can point to items, a tactile bridge between counting and multiplication, counting being this very basic math skill that we learned so early in life that is related directly to multiplication, and arrays allow us to see that relationship close up. So I think the easiest way to really see the power of arrays is to start using a few. So we see here a pop-up fidget. And this pop-up fidget has 6 different colors with 6 different bubbles in each color. So it's a 6 by 6 array. And we could count them. If your child had this in their hand, they could pop the bubble while counting. And so they could count how many bubbles are there. They could skip count. They could, so 6, 12, 18, 24, practice skip counting by 6s. They could use addition. They could say 6 plus 6 is 12. 12 plus 6 is 18. 1, 2, 3, 4, 5, 6. 18 plus 6 is 24. And they might do various combinations of these items so far. And eventually the goal is to naturally lead students through these early stages to this idea of multiplication as a faster way to achieve the end goal, but still closely related to all of these other ideas. So just to practice, just to enjoy the process a little bit, can you count how many biscuits there are? One by one, 1, 2, 3, 4, 5, 6, so on and so forth. Can you skip count? Are there 2 ways you could skip count? Can you use addition? Can you multiply to find out how many biscuits there are? Pause if you need a little more time to explore this. Similarly here, now we have 2 file drawers of tissue boxes. There's a teacher who has stocked 2 file drawers full of tissue boxes, hoping this will last the year. We can't see a good chunk of them because the drawers are covering them. So counting them is going to be a little tricky. But can you skip count? Assuming that that bottom drawer is full. Can you use addition? Can you use multiplication to count these tissue boxes? Pause if you need a little more time. Think about why would we want to use some of these higher level methods, in particular multiplication. What does multiplication gain us that the others don't have? One answer to that is speed. Here's an array of arrays. So there's lots of different things we could count here. We could count how many of these little stuffies fit in one box. We could count how many different boxes there are, how many different kinds of stuffies there are. There are many things you could count. What will you count? What would your child count? How will you count them? How would your child count them? And how does this process of organizing them into arrays or this structured rectangular format help make that counting easier? So sometimes these arrays can help us see what's missing. So what will you count in this picture? How will you count them? And how does the array make it easier? When you count your item, did you use subtraction? Is there a counting that you could use subtraction on? We can use these arrays ideas to tie lots of operations together. Here's an array that can really bridge all the way from toddlerhood up into even high school. You could have a toddler count how many colors they see. You could have a lower elementary school count how many rectangles. You'd have an upper elementary count how many tiles. A high schooler or middle schooler could count the size of each of those colored rectangles and start to talk about sequences and sequencing and growth. What will you count, and what patterns here help you count? These are all what we call low floor, high ceiling opportunities, where there is an in for students at any level to start talking about this and to notice things right at their level that allow them to explore mathematics. Sometimes things that look like arrays aren't really arranged in a way that help us to count very well. These rows are a little messy. These columns are a little messy. We can't really skip count. We can't really multiply. We might be able to use some type of addition to speed up this counting, or we might need to just count. So these messy columns, these messy rows, don't really help us count very well. Same here. We have rows of 6 radios, rows of 5 radios. What would make it easier to count these? There's no one right answer. There are many things you can do to make this easier to count. Pause the video if you need a little more time. So here we start looking at an example of how this might be used in a classroom and how your child might have seen this used in a classroom. We see the teacher over here on the right reflecting the students' thought processes about the array that they're shown here on the left. And you can see the students noticing there's 5 rows and 5 columns. You can see them using that addition, 5 plus 5 plus 5 plus 5 plus 5. We can see them recognizing that it's a 5 by 5 array and drawing it and abstracting it. The teacher abstracts it for them to draw a 5 by 5 array on the board. They start talking about a diagonal, which is a meaningful term because this is square. We see children going through a skip counting, 5, 10, 15, 20, 25. And we see children starting to realize that this is a multiplication problem. We even up here in the corner see children starting to bridge this idea of this 5 by 5 array to the area model of multiplication, which is kind of the next stage in visualizing multiplication, as well as connecting multiplication to division. And we see some much higher level thinking here of squaring the 5. So we see ends for multiple levels of thinking, and we see the students being able to connect to each other and bounce ideas off of each other. All right, so how can you as a parent help your child use this tool? One way, if you're given a homework problem and they're asked to create an array, is to help your child line up rows and columns carefully. You can either do this on paper, or you can get out building blocks and have them build an array physically of the size that they need, if they need that tactile experience with it. But have them help them to learn how to line them up carefully so that they can build these higher level skills. Allow your child to succeed at getting that final answer using whatever strategy they're most comfortable with. If they need to count, if they need to touch each item and count, allow them to do that for a while. If they can skip count, allow them to use skip counting or addition. And eventually we're hoping to build them up to multiplication. But if you force that upon them, then it's going to be a meaningless process. And that's what we really don't want. We want those numbers to make sense to them so that when they are multiplying, there is a sense behind that. And they can learn when as well as how and why. So again, allow them to use their hands and bodies. Pull out those blocks, pull out paper clips or whatever you need to, whatever you have at hand. If they need that tactile experience, allow them to do that. They're doing that in the classroom as much as is feasible for each class. Give them that opportunity at home as well to explore those ideas, those mathematical ideas with their full being and all of their senses. Once they have succeeded using a strategy, go back and encourage them playfully to try it using the one level higher. So, okay, so you counted these. How could we count by 5s to get to our final answer? Or if you skip counted by 4s and got an answer of 12, what does that mean that 3 times 4 makes? Right? So playfully encourage your students to bridge into that next step. Know that just because they multiply on one problem doesn't mean that they'll see the multiplication on the next problem, and that reverting to an earlier strategy is okay. That is an okay and a normal thing to do in development of thinking. And watch for arrays everywhere. Talk math with your kids. Find arrays. What might they count and how? And this has been Math Teacher Barbie, and I hope this has been helpful in learning how to use arrays with your student.